Okay, chapter 15. And I think this is what I have as my slide number 10. Is that about where she got to? Did you name these?
Yes, we did. We mainly worked out of the book.
You mainly did what?
Worked out of the book.
Worked out of the book.
Sample problems out of the book.
Okay.
The problems. For those of us who didn't have the book, we write it on the board.
Okay.
Give us a few minutes and we can read.
So you mostly got through what are amines and how to name them. Is that basically it? So let's just real quickly name these. I'm not, and I'll be recording this on, and then maybe we'll come back and just skim through slides 1 through 9 again real quickly at the end. But let's make sure we can cover all of chapter 15. All right, so let me just tell you this in terms of naming, and I'm sure Dr. Prasad probably emphasized it as well. Amines are tricky because there's really three ways of naming, three systems you could apply to name an amine. Simple. Okay, pardon me?
Which made the homework so confusing. Like, I don't know if I used the right naming system for the different problems.
Well, on your homework and on your test, when it comes to chapter 15 and naming amines, if I give you an amine and say name this amine, if you give me an acceptable name of it by any one of the three ways of naming them, it will be counted correct. All right? So let me explain that quickly. There's simple amines, and we're going to just use simple names for them. And then there are two IUPAC ways of naming them, two different acceptable IUPAC systems. If you can use a simple name, use a simple name. Example, right there. That is dimethylamine. That is a simple name. Now, I could give you the IUPAC name for that, and that'll just confuse you. It could be, let's see, it could be, there's two IUPAC names for it. But let's not go there. This dimethylamine. This is a simple amine. What is that? Methylamine. And this is a simple amine. What do I mean by simple? If there's nothing but ethyl and methyl groups on the nitrogen, then it's a simple amine. What would that one be? Yeah, okay, diethyl-methylamine. Now, I can look at that name, diethylmethylamine, I can look at that molecule and classify that amine. What class does that fall into? Tertiary. Tertiary. It has three things attached to the nitrogen. There are three things on the nitrogen. That's a tertiary amine. What kind of amine is that? Secondary amine. And this is a primary amine. And when you have that situation, so methylamine, I'm going to have a methyl group here. I only got one thing on the nitrogen. There has to be three things on the nitrogen. So the other two have to be hydrogens. So I'll give you the name. If I say draw methylamine, then you draw a nitrogen, you put a methyl group on it, and you say to yourself, well, there needs to be two more things here. I don't see them in the name, so they must be hydrogens. Okay? So that's how you can go from a name to a structure, and how you can go from a structure to a name. Okay, and not, so this one could be methylpropylamine. It could be that. But even when we get up to propyl groups, then you guys say, well, is that propyl? Is it isopropyl? But if you gave me the name methylpropylamine, I would accept that.
What about the N?
Yeah.
The what?
N at the beginning of the methyl. Isn't that one of the rules that if it's a secondary or tertiary, you do the N in the beginning of the name?
Like which one? You mean this one?
Yes. Methyl one.
Propanamine?
Is that only for the IUPAC name or is that?
Yeah, that would be an IUPAC name. That wouldn't be a simple name. And that would, that could
Simple
be,
name you mean by the common? Common.
Yeah,
which
common.
We only look at the groups.
right. Simple or common, but simple amines. Simple amines have small, I was wondering what that little thing was right there. That's our oxygen from the quiz. Okay, here we go. Simple meaning methyl and ethyl groups predominantly. But even this one right here, if you had, let me just, maybe I can get it over there. Let's see if I can get it over there. If you had this, see there's a propyl as well. But then now this is an isopropyl. So even when you get up to propyl, it starts getting a little confusing. I mean, if you told me this was methylpropylamine, I'd say no, that's not right. Propyl to me is that in a line, so this would be methyl isopropylamine, or you could start going into the IUPAC naming. Okay, now Jocelyn, you were starting to talk about using the N, and I'll introduce that here in just a second. But let's take, you would have to use the N on a word like, on a molecule like that. And here would be the parent name right there. Okay, now the IUPAC name of that, I've got it longest chain, 1, 2, 3, 4. So that'd be butane. So let me draw that one over here. I'm going to have 1, 2, 3, 4. I've got 1 here, and I've got 2 here. So this is my parent name right here. Longest chain, 4 carbons, so butane is going to become butanamine. We're going to take off the E. And the N is on what carbon on the butanamine? On the first one. And so, I wish I had moved that over there a little further. So we got 1 butanamine. And so now we've got N-ethyl dash N-methyl dash 1 butanamine. So butanamine is saying we got an amine group, a nitrogen, on the end of this 4-carbon chain. On the end, on the first carbon, this is carbon number 1. But what else? We don't have just two hydrogens. In other words, butanamine, one butanamine is this. You with me? That's one butanamine. It's a 4-carbon chain with a nitrogen at the end. What have I mentioned? Only a butane, nothing else. So the amine group on the end is truly an NH2 group, just a simple amine. But in this case, my amine has a methyl and an ethyl group on it. So I'm not using numbers here. I'm not using numbers because numbers are only going for the carbons. But I'm using the N to tell me where that methyl group is. It's on the nitrogen. Or where that ethyl group is. N-ethyl, N-methyl, dash 1-butanamine. Okay, and that's an IUPAC name. They won't always have an N in them, but you won't be using N for simple amines. Trimethylamine is not going to be N-methyl, N-methyl methanamine. That would be the IUPAC name of it. Okay, so if we had this little molecule right here, this is why I'm saying if it's simple, just call it trimethylamine. Because to go to IUPAC, there's your longest chain. So that's methanamine. And what is it? It's NN dimethyl methanamine. So that's an IUPAC name. Not simple. IUPAC, not IUPAC. That's an IUPAC name. You can see the simple name is a lot smaller, a lot shorter and simpler. Trimethylamine. Okay, I know. Okay, I don't know how not to confuse you with the name of amines. It gets confusing. This is one IUPAC system for this molecule. The other one is to treat the amino group as a substituent. Let me just give you an example. There is where you could just use it as a substituent. This is an amino substituent. What carbon is it on? 3. So this would be 3 amino pentane. All right, so I'm not calling it 3 amino pentanamine. That's the other system. This is where you're treating the amino group as a substituent on pentane. Just like you would treat a methyl group. I mean, if I had a methyl group there, it'd be 3 methyl pentane. This is 3 amino pentane. This is also an IUPAC name. Or this is 3-pentanamine, which is the other IUPAC name. So that's why I'm saying there are 3 ways of naming amines. Simple, you can't name them all simple. This is not a simple amine, so you have to use an IUPAC name. Follow me? You have to use an IUPAC name. But see, Jocelyn, there's not an N in this name, even though it's IUPAC. There's not an N in there. Both of those would be correct. These are both correct names for that molecule. Either one of them. This is what I prefer. That is my baseline. That would be what I would present to you and say, when you can, treat the amino group as a substituent. And you can see the book will use both means. It'll take you through both ways of naming them. So if on the exam, if you see a molecule, here's an amine, and it says name it, or what's the correct name of this amine, and you give me either 3-aminopentane, actually it'll mostly be multiple choice, so you're going to have to look for a acceptable name for that molecule. One of the 3 ways of naming it.
You could probably only do that with the primary ones, right? Like, even as a substitute.
Okay. Well, let's see if I can leave that in view, and let's go over here. Draw it a little bit smaller, and let's put a methyl on there. Okay, that's a secondary. So this is still 1-amino. Pentane. But what will we also include now? Yeah, and how do we say where that is? N-methyl. All right, so you can use this. You can use this way of naming things for a secondary or a tertiary. You could have 2 methyl groups on there. Be N, N dimethyl.
I think that's too confusing because there's like an N and a number.
Yeah.
Can we
So-
just skip this turn? Oh my god.
Amines.
And you said this is gonna be in the test, right?
Yes.
Oh my god.
All right.
Why is it 1-amino? What's on the third?
Oh, I'm sorry. Let's see. It's 3-amino.
Oh.
I'm sorry. That is 3-amino. It's 3-amino N-methyl pentane. Yeah, good catch. It's still on the 3rd carbon. So it's 3-amino N-methyl pentane. Okay, let's move on. Let's do some more. We're going to get to aniline, and then we'll see how we use the N with aniline. All right. Nomenclature of aromatic amines. Well, I got writing all to the side of this slide. You should have a 3x5 card on this one. There's your benzene ring with your NH2 group on it, and its name is aniline. So memorize the name and structure of that molecule. That'll be on the test. There you go. It's giving you one of the questions. All All right, aniline. You don't need to memorize all of these, but let's look, and I'll get a clean slide over here, and we'll work on this. We're going to work off of aniline and see how we would name some derivatives of aniline. Okay, so let's look at aniline here. Sorry. All right, so if this were aniline, and this is aniline, so now let's take this molecule. So this is called aniline. Let's take this molecule. All right, now I'm trying to challenge you here, and let's take a look at this molecule. Maybe I should just write on the board. I'd like to capture this, but I don't know what's happening. Let's see if this writes now. Okay, there we go. We got 3 molecules here. This is aniline. Now we've put a methyl group on aniline, but we put it in 2 different places. In this one, we put it on the nitrogen, and in here we put it on the benzene ring. Now, if you stopped and analyze those molecules for a minute, you would find out that they have the same exact molecular formula. They are isomers of each other. Because look at this, there's a hydrogen and a methyl here. Here we got a methyl here, but there's a hydrogen here. So if we take that hydrogen and move it up to there, and that methyl move it down to there, we haven't added any. We've got the same number of carbons, hydrogens, and nitrogens in both of those molecules, but they're going to have different names. So that's aniline. So what do you want to call this? The parent name is going to be aniline and methyl aniline. Where's the methyl? It's on the N. I like to use these 2 examples right here to show you how we're using N just like we would use a number. Okay, now the parent name of this molecule is going to be aniline. All right, that's aniline right there. So this is aniline. Where is this methyl group? On the 3rd carbon. If this is aniline, that's carbon number 1, that's carbon number 2, that's carbon number 3. This is 3-methyl aniline. Okay? Does that help you see where the N is in a name, is being used just like a number, but the numbers are always going to be pointing to a carbon, not a nitrogen. If the group, the substituent, is on the nitrogen, then we don't use a number, we use a capital N. It needs to be a capital N, not a little n, capital N. N-methyl aniline, 3-methyl aniline, and aniline. Does that help a little bit? The more we do some of these, you know, I know it's confusing. I know it is. Naming amines is probably the most confusing molecules to name. And even for organic chemists, you know, two organic chemists will walk up and one will be talking about pentanamine and one will be talking about 1-aminopentane. And so, you know, okay, you like to talk about it that way, I like to talk about it this way. And so they have to kind of try to understand each other. It's not as confusing with alcohols and other molecules because they don't have two alternate IUPAC ways of naming them. So that's just unfortunate, but that's the way it is. All right, so there's just a few more examples here. So there's N-methylaniline. Here is 2-ethyl N-methylaniline. And here is N-ethyl N-methylaniline. The ethyl and the methyl are on the nitrogen. All right, and I like to go by aniline. Yes, benzamine. If you Googled this, it would say, okay, an alternate name is benzamine. But this is so common, you don't typically see a lot of people calling it benzamine. Don't worry about these toluidines. You don't have to worry about memorizing those. This is this is something I missed back in chapter 11, the ortho, meta, para. I missed this, didn't I? I did not teach you this. I knew I didn't do it, and I was going to actually try to make a video of it and put it up on the website because we overlooked it in chapter 11, I think. Ortho, meta, para. What we're saying here is this is the ortho position, this is the meta position, this is the para position. This isn't just got to do with aniline, this has got to do with benzene. Benzene. Anytime you have it. Well, I won't go into that right now. You're already confused about the amines. We don't need to jump into that, but we'll come back to that. All right. How many slides are there? 41. Which slide is this? What number is this? 13. Okay. Okay, let's bounce along here. Physical properties of amines. I'm not going to dwell on it too much. There is some polarity to a nitrogen-hydrogen bond. It isn't as polar as an oxygen-hydrogen bond. It's not quite as polar. But the nitrogen is going to attract the electron, so it's going to be the negative part of that bond. The hydrogen is going to be the positive. So you can get hydrogen bonding between a nitrogen and an oxygen, and between a hydrogen and a nitrogen. So there is some polarity. Their boiling points are going to be higher than the alkane, just a simple alkane, but lower than an alcohol. All right, so there is some solubility in water. So you introduce a water molecule, the hydrogen on the water can hydrogen bond to the nitrogen, the oxygen can hydrogen bond to the hydrogen on the nitrogen. So hydrogen bonding. So there is some solubility in water. When things are polar, boiling points go up, solubility in water goes up. Okay, reactions. I'm going to skip that reaction. How to prepare amines. That actually, the way they're preparing it, they're reacting it with an amide. And we haven't gotten to amides yet. All right. Okay, I'm going to slip one in here before we get to neutralization. I want to just talk about dissociation. Let's go back to our 1305, ammonia. And you should remember something like this from 1305. That ammonia plus water, you get the ammonium ion and the hydroxide ion. And this is where you learned that ammonia, now remember amines are, what are amines? Amines are organic derivatives of ammonia. Yes? All right, so ammonia will react with water to give the ammonium ion and the hydroxide ion. Now, does the hydroxide ion make the water acidic or basic? Basic. So ammonia is what we call a weak base. Well, it turns out, oh, what happened to my slide? Where'd it go? Come on back here. Touchy. These touchy screens are really touchy. I lost it. Where are you? You're floating around in space. There we go. All right, now let's take ammonia and let's make an organic derivative of it, a simple one. So this is methylamine plus water. Same sort of thing happens. We get this has got a positive charge on it. All right, we're taking one of the hydrogens off of this water, and it's being attracted to this nitrogen on the amine, just the same way that hydrogen was attracted to that nitrogen in ammonia. And what's left over? If we take a hydrogen off of that water, what's left over? A what? Subtract a hydrogen from H2O. OH. So amines are weak bases. Ammonia is a weak base. Amines are weak bases. They make the water basic. It raises the pH of the water. And methylamine becomes methyl ammonium hydroxide. This was ammonium hydroxide. This becomes methyl ammonium hydroxide. You got it? Ammonia is the weak base. All right? That's what it becomes as a result of reacting with the water. But it's the ammonia, it's the methylamine that are weak bases. They produce hydroxide ion when you bubble them into water. Okay, so that's just a way they'll dissolve in water and cause the water to dissociate. So the dissociation of water as a result of these amines to create a weak basic solution. Okay, now I've just told you they're weak bases. So a base will react with an acid to form a salt. Usually salt plus water, but in this case, that's not what happens. So let's take a simple amine. That's methylamine, just what's right above there, plus hydrochloric acid. So an amine plus an acid is going to form NH3 or CH3 NH3 plus Cl minus. So methyl amine plus HCl becomes methyl ammonium chloride. methyl ammonium chloride. This is neutralization. Why? Because we're reacting this base with an acid, neutralizing it, it's forming a salt. It doesn't form a salt plus water in this case because our amine here does not have an OH on it, so it doesn't form water as well. It just forms this salt. The salt consumes everything. The amine and the acid end up as the salt. That's your end product. And I usually write them with this salt. We write sodium chloride like this. We don't usually put a plus and a minus, but it is an ionic compound, sodium chloride. Methyl ammonium chloride is this positive ion, the methyl ammonium ion, and the chloride ion. Your homework, I think your homework has a molecule that is got the ammonium and a chloride, and it's asking you to name it. So you can see, whenever you see the positive here, you're going to see the word ammonium. You wouldn't say ammonia. Ammonia is NH3. Amine is an NH2. But the ammonium has a +1 charge on it. It's gained a hydrogen. Let me just quickly draw that. See, what you have there is this. There's your methyl group. You have a hydrogen, you have a hydrogen, you have a hydrogen. Now, Dr. Prasad probably told you that the nitrogen, that a nitrogen is going to have 3 bonds. Oxygen has 2 bonds. Carbon has 4 bonds on it. This is the amine. There is a lone pair of electrons up here. You get another hydrogen on here. It doesn't bring any electrons. It's just a proton that comes in here. So this thing ends up having a like methyl ammonium ion. Now, whenever nitrogen has 4 things around it, it's going to be positively charged. It's going to have a +1 charge. So don't ever think that just in an amine, you'll never, I shouldn't say that. I'm going to show you one in just a second. You'll never have that. No, I didn't say that. Okay? So this is neutralization, an amine plus hydrochloric acid, and I won't work with any other acid than HCl. You form this salt. Now let me tell you one of the practical consequences of this. You think this doesn't matter. If any of you are taking a prescription, or if any of you are taking a supplement, you look at the label. You look at the label carefully. And not all of them will say this, but many of them will say it. It'll say L-lysine hydrochloride, hydrogen chloride. What is L-lysine? L-lysine is an amino acid, and what you'll see, it's an amino acid with an amine group down here. We won't worry about the rest of the structure of that amino acid. That's L-lysine. But they're saying, okay, this is L-lysine hydrochloride. What do you mean by that? Well, there's going to be 3 hydrogens here. It's going to have a plus charge. There's going to be a chloride ion on there. Why? Well, that's more soluble in water. That is more soluble in water than the amine is itself. This molecule right here is more soluble in water than this molecule. Okay, follow me? And what does that mean? You swallow a pill with this in it, more soluble in water, more bioavailable. It will be absorbed into the body more readily. And so even drugs, you might be on a prescription and it has a nitrogen in it, has an amine group on it, they will react it with hydrochloric acid so that it will, instead of only getting 30% of it into your bloodstream, you'll get 45 or 50% of it will go into your bloodstream because it's more soluble in water. So this is used very, very often with supplements and things that they're actually trying to administer through ingestion. They do this quite often. So if you ever see hydrochloride or HCl on the label, the ingredient plus HCl, this is what they're doing. They're converting it into a more bioavailable form of the drug. Okay, you ready to move on? I know I'm moving fast. We're going to go on now to quaternary ammonium salts, or quats. Quaternary ammonium salts. All right, a moment ago, if I had this molecule, and I reacted that with HCl, trimethylamine plus HCl, what would I get? I would get the trimethyl ammonium chloride. Trimethyl ammonium chloride. I would end up with a nitrogen with 4 bonds around it. 4 bonds around it. The H would go on the nitrogen. The chloride would be attracted to that positive ion. You get trimethyl ammonium chloride. Well, what am I reacting it with here? This isn't HCl. This is methyl chloride. Methyl chloride. So instead of getting a hydrogen here, I get another methyl. Well, I got a nitrogen with 4 methyl groups around it. It still has 4 bonds around it and a +1 charge. That has a +1 charge. This has a +1 charge. This is tetramethyl ammonium chloride. Tetramethyl ammonium chloride. Tetra. Quat. Like a quartet. We've got 4 things around that nitrogen. 4 organic groups. That's a quat salt. Very important in biochemistry. All right, this will come back up in chapter, what chapter? 18, 19, I think we'll see. Maybe even 17. I think we got some examples right. Yeah, here's some examples right here. You've heard of these. You've probably heard of these. Choline, acetylcholine. Look, here's a nitrogen, there's a carbon, and here's 3 more methyl groups. So we got a methyl, and a methyl. And we got a carbon attached on this side. So we got a nitrogen with 4 carbons around it. That's a quat salt, and it's a naturally occurring neurotransmitter in your body. Your body's making that quat salt. So that's choline, and if you put an acetic acid group on here, you're forming the ester. That's an acetylcholine. Here's the rest of the molecule. That's your choline, but you got an acetyl group on it. You don't have to memorize the structures of these. The point of this is to show you that quaternary salts are naturally occurring and important molecules in your body. Yes, Adrian.
For it to be quat, it has to have 3 carbons around it, or could it just be SE3? I mean, it's 4 just groups around it.
4 carbons.
It has to be carbon. So like when
They don't have to be methyls.
But they have to be carbon.
They have to be carbon.
So like whenever you use the example, you put HCl on it, that isn't put on here. Take the example like above it, and you put CH3, HCl. Didn't you? Yeah, right there.
This one?
Yes. No.
That,
That one right there.
yeah, this is not a quat salt.
It's not.
No, this is just this is the tertiary amine reacting with HCl. I'm just showing you the analogy here. We don't have an H here, we have a methyl. So we don't get an H here, we get a methyl here. That's a quat salt. That is not a quat salt. Quat means 4 carbons. And they don't all have to be methyls, but they have to be carbons. Notice here, what do we have here? We have let me see if I can fit it right here. We've got a methyl. We have a methyl. We have a methyl. That's what this is all about. 3 methyls. And now we got another carbon. But that's not a methyl. That's an ethyl group. It's an ethanol. It's an ethyl alcohol group attached to that nitrogen, but there are 4 carbons around that nitrogen. So that is a quat salt. Just 4 carbons. So yeah, you just have to have this situation. And those carbons can go on and be attached to other carbons. And you got a quat salt. Yeah. Yeah, due to their ionic nature, amine salts are more soluble in water than the parent amines. Hence, amine drugs are converted to amine salts for easier absorption, more effective absorption into the body. All right, just a term to be aware of, heterocyclic amine. What does that mean? What does that mean? Oh, man. Amine, heterocyclic amine. These are ring structures that have carbons and nitrogens, or heterocyclic just generally means there's at least two different elements in the ring. In the ring. They have to be in the ring. So here's a pyrimidine ring, 2 nitrogens and 4 carbons. Purine ring, we got 4 nitrogens and 1, 2, 3, 4, 5, 6 carbons. All right, you don't have to memorize these either. This comes in chapter 20 because these rings make up DNA. This is the basis for the nucleic acids. They are heterocyclic amines. DNA and RNA. DNA and RNA structures include these purine and pyrimidine rings. So that's just a vocabulary word for you. What is a heterocyclic amine? It's cyclical structure that has nitrogen and carbon. Okay, now the second part of chapter 15, the minor part of it, the amines are the major part of it. The minor part of it is amides. What is an amide? Amides are important. An amide, you have the carbonyl and an amine attached to it. So R means, R can be anything. It could be another carbon, another 4 carbons, a benzene ring, whatever you want it to be. But this is your basic amide structure right here. You got a carbon-oxygen double bond, and on that particular carbon, you have a nitrogen on that carbon. That's an amide. All right, this is not an amine. This is an amide. All right, now, and here's Yeah, so here's your amide functional group right here. So, something coming off there, but there's the essence of the amide right there. How do you name amides? Well, you don't need to do a deep dive here. If I just told you there's well, I think there's a slide here that has a few amides that I basically say know those amides. There's about 3 of them. You can get the flavor of it right here. Now count that carbon. 2 carbons here. So this is because some people look at that and they call it methanamide. They see the methyl group and the amide group and they say it's methanamide. That's wrong. There's 2 carbons here. So the longest chain is 2, so it's F. If this were a hydroxyl group, it would be ethanoic acid. But the hydroxyl has been replaced by an NH2 group. So, and that's your amide functionality group, so it's ethanamide. Ethanamide. Now the common name for that molecule is acetic acid. If that were an OH, that would be acetic acid, right? Yes? Okay, stick with me. Think fast. I'm talking fast. I want you to think fast. Acetic acid, but it's not acetic acid. We got an amine group there, an amide. So it's going to be acetamide. Acetamide. Or acidamide. Some people, I think more people pronounce it acidamide. Okay.
Are those the 4 you want us to know?
No. Here are the 4 I want you to know. This one. Okay, you see there's only 1 carbon there. There's no methyl group there. Just 1 carbon. So that's methanamide. If that were an OH, you'd call it formic acid, so it's formamide. And you should know the IUPAC name and the common name for formamide. So you now know formaldehyde, formic acid, and formamide. All of those forms have 1 carbon in them. Formaldehyde, formic acid, and formamide. Where's the other one? Ethanamide. There's 1, there's 2. The third one's not on there. The third one would be this one. This is the third one. This is benzamide. Yeah, benzamide. So it would be benzene, but it's benzene with an amide functional group on it. So it's benzamide. So those are the only 3. This one, and this one.
What's the other name for it?
For benzamide, I think that would be the only, that would be the common and the IUPAC name for it, benzamide. Properties of amides, don't worry too much about it. Chemical properties of amides. I won't go into any reactions of amides. Biologically important amides, or wait a minute, amines. Amines. So there's dopamine. Heard of dopamine in the brain? Epinephrine. So dopamine is a primary amine. Epinephrine is very close to that molecule, very close. You've added an OH group right there, and you've added a methyl group there. So this is a secondary amine, epinephrine.
Is that used for epinephrine for like you have a allergic reaction?
Yeah, an EpiPen. Yeah, that's adrenaline.
Right.
Yeah, that's your EpiPen. Epinephrine. Epinephrine is not it's a naturally occurring molecule. This is adrenaline. It's a naturally occurring molecule. You don't need to memorize these structures. But notice, dopamine is telling you. It's an amine. What organic class does dopamine fall into? Amines. Okay? Trying to help you out here. I don't know if that's one of the questions. Serotonin, histamine. Histamine. So antihistamines are trying to suppress your body's production of that histamine. What class of organic compound does histamine fall into? All right? Are these simple questions? All right, here's your quaternary ammonium, your quat salt here, acetylcholine, we mentioned that. All right, there are lots of slides that just to convince you that nitrogen-containing compounds are biologically active. They're very important biologically. So when we get into biochemistry, you're going to start seeing these functional groups all over the place. There's nicotine, caffeine, codeine, morphine, heroin, these drugs. Amphetamines. All right, you've heard these names. Now you kind of know why they're called amines. Benzodrine, methadone, Novocaine, Demerol, nitrogen-containing things. There's ephedrine, pseudoephedrine. All right, there were a lot of slides, but there are just a lot of molecules. Pentothal, an anesthetic. Pentothal, Valium. If you got into Aleve, Tylenol, aspirin? Aspirin is acetylsalicylic acid. It doesn't have a nitrogen in it. But Aleve and Tylenol and what's the other one I'm thinking of? A lot of those pain medications have nitrogens in them. I think there might be a question on your homework about this aspartame. Is that on there? Okay.
Yeah, explain why aspartame containing foods carry a warning. Why does neotame not carry that same warning?
So where's neotame? Neotame here. Aspartame here. Okay, phenylalanine. Trying to remember. I mean, if you hydrolyze that bond, you release phenylalanine. You better look this up. Because there are people who are PKU, phenylalanine ketonuria. They cannot metabolize phenylalanine, and if they take aspartame or NutraSweet, it can hydrolyze in the body and release phenylalanine. I guess maybe they've modified the aspartic acid, and maybe this one doesn't hydrolyze in the body, so it doesn't release phenylalanine.
In the book, it said that it contains 3,3-dimethyl-butyl, and it blocks the breakage of the amine bond.
Yeah, there's your what, 3,3-3.
3,3-dimethyl-butyl,
Yeah, there it is right there.
and then that blocks the breakage.
Yeah, and that blocks the hydrolysis of that bond. So this is stable in the body and won't release phenylalanine. This one will break that bond. Your body will metabolize that and hydrolyze that bond and release phenylalanine. And so someone that's PKU sensitive, I think that's a genetically acquired disorder, then they can't take aspartame, or they need to take it cautiously. Okay, what slide is this? What number is this one?
Still got it. Oh no, that's 36.
Look at that. Okay, there were a whole bunch of slides in there of just examples of nitrogen-containing molecules, and you don't need to know all of those. All right, so in terms of reactions, there's not a lot. Here's your basicity of amines. Know that reaction. Here's your neutralization of amines. Know that reaction. I think the other one I would know is be aware that, go back to the slide where you see a tertiary amine. It's a tertiary amine. It reacts with methyl chloride to form a quaternary ammonium salt. All right, so know that reaction. And we're not going to dive into these other reactions. Okay, and then the other slides, this is just chapter 13. This is chapter, what is this? Chapter 13. This is chapter 14. And then the other slide is chapter 15. That's all your reactions. Okay, now, where'd Deborah go? I was just going to ask Deborah how she's doing on chapter 15 homework. How are you doing on chapter 15 homework? Do we need to go back and look at those first 9 slides?
Yes, please.
All right, so chapter 15 deals with these two functional groups, the amine and the amide. All right, this is just showing you, okay, the amines are organic derivatives of ammonia. Here's what ammonia looks like. It's got this lone pair of electrons up here, so it generally forms 3 bonds with something. So if you replace one of these hydrogens with a methyl, you've got a primary amine. You replace another hydrogen, you got a secondary. You replace the third hydrogen, you got a tertiary amine. So that's the classes of amines. Here's methylamine is primary. Dimethylamine, secondary. Trimethylamine, tertiary. So know the classification of amines. Classify these. What is that? Tertiary. The next one? Primary. Next one? The next one? Next one. And the last one? Secondary. All right? No hydrogens on it. It's tertiary. One hydrogen, two carbons. Yeah, just the number of carbons. 2 carbons, secondary. 3 carbons, tertiary.
You said with the substituent of amine, what do you formally if it's used as a substituent? Amino.
Yeah, amino. Yeah. Yeah, the substituent name is amino. It's an amino group. Hydrolysis? Hydroxyl? Hydroxy or hydroxyl is that. Just an OH. That's a substituent.
Can you do problem B from the homework?
Problem B. Number 2B. And what's that? Just to name it?
Yes. Is it one?
1, 2, 3, 4, 5. So it's got 5 carbons. Okay, so this is carbon number 1, 2, 3, 4, 5. So what's the parent name? Shall we go with pentane? Shall we handle it like a substituent? Pentane. Pentane. Now it is 1 amino pentane, and what else? 4 methyl. And I don't need a number here because I've just told you where that amino group is. All right, so I don't need a number in front of pentane. I said it's 1 amino 4 methyl pentane. And remember, this is a little bit review. Remember I said there's 3 parts to a name. There is other or miscellaneous. There's alkyl groups. And then there's your parent name. All right, now this is IUPAC. All right, that is the way I prefer to do it, treating the amino group as a substituent. The alternative way is to put it in the parent name. The other way of doing it is to put the amino group in the parent name. So you end up with a parent name like this, pentanamine. Now in this case, we need a number. All right, because I've just said I've got an amine functional group on this 5-carbon chain. Where is it? It's on the first carbon. So it'd be 4 methyl 1 pentanamine. Which way do you want to name it? These are both correct.
The problem that I really had a question about was D, because it had the N plus and the Cl negative. I wasn't sure how we were supposed to name that.
Oh, okay, there you go.
Honestly, this homework is really hard.
This homework's hard?
Yes. Like the whole thing.
Like the whole thing's hard?
Can we just do the whole thing?
Okay, now 7, aniline. You should be able to draw that. 7, pyridine. You can find that. Purine, find it. What is a quaternary ammonium salt? Write out the structures and complete the reaction for 1-amino pentane plus HCl. Write out the chemical reaction of ethylamine with HCl. Look, I don't even have a quaternary ammonium salt. I just ask you to define it. All right. Let's go back over to 2D.
Can you go to the screens of like the aniline and so you just copy it?
Yeah, you can go in the book and find aniline and go to the screen.
Yeah, right now. So you just copy. I mean, isn't this due in the class?
Yeah. Yeah, let me do, let's look at 2D for a second because that's something you could easily do. But let's do 2D. Let me walk you through 2D. Let's do it this way. Let's start out right here. What would you call that? What would you call that? Diethylamine, right? But what?
What isn't that like secondary?
That's diethylamine.
Oh, you're writing the.
Okay, now, yeah, that's the simple name of it. Now, what do you have in 2D? 2D, you have this.
Then it's H2 and Cl.
Let's put this hydrogen that was right there up there. So let's just pretend this is diethylamine. And then what do you have? You got another hydrogen and a chloride. How did you get that? Well, that's how that was made. It was made from diethylamine plus HCl formed 2D. The compound that you see in 2D.
Does it matter if it's H2Cl? Because on paper it's H2.
Well, there's your H2. There's 1, 2. Right? There's your 2 hydrogens.
Okay, but so does it matter that it's like it said H2? Like it doesn't make a difference.
No, it doesn't make the difference. I'm just drawing the structure. So, I mean, we could, I just wanted you to see,
How it would be made
I just wanted you to see that it looks just like that. It's just got an extra hydrogen and a chloride. So diethylamine became diethyl ammonium. Remember, I said when it's got a +1 charge on it, it's not amine anymore. The name has to change to ammonium. Whether it's a quat salt or reacted with HCl, when it's got a +1 charge on it, this is what its name's going to be: chloride. Diethylamine becomes diethylammonium chloride. You follow that?
What would be the IU pathway?
Well, that would be ethanamine. So it would be N-ethyl ethanamonium. Ethanamine would become ethanamonium. Okay? You don't want to go there, actually. I mean, I can answer that question. But what I'm saying is if it's simple, keep it simple. All right? If you just see ethyls and methyls, then just
Go that way.
go that way. Keep it simple. If you did give me an IUPAC name and it was what it should be, then I would take it.
So if it was to have a ring on it, it would be benzalonium?
It would be aniline.
Oh, yeah.
Aniline, if it had a benzene ring on it.
So that's aniline, C, over to the C.
Yeah, let's see.
It doesn't have the,
It's a ring attached to an N and then a methyl group.
Oh, you mean 2C?
Yeah.
Okay. Struggle with that one.
It doesn't mean.
Does that mean?
What did you say?
We had a request. I said struggle with it. Okay, there you go. There's aniline.
It's N-methyl.
I'm helping you with your homework.
I know, I got it.
You got it.
No, with this one. So it's
Okay. How should we do the chapter 15? You could turn it in now. You can turn it in tomorrow. Probably even turn it in Monday morning if you wanted to. Tomorrow's Thursday, right?
Yeah.
Oh, let me. Let's see here.